Alright, picking up where we left off. This is actually the second time that I have to record this video, because I went over by about, I don't know, 16 seconds on the first time I tried to record this. Um, so if I'm sort of jumping around here, then and that's why. It's, I just rewatched the video that previous to this, and so it's kind of fresh in my head. But this is all sort of, it's not stream of consciousness per se. I'm not, Jim Morrison of the Doors or something up here just rambling. But the context is difficult to hold it all in your head at one time. And even, if I go back and I watch the previous videos and I make a sequel or something like that, I mean, I don't necessarily remember exactly what I was thinking at the exact point. At that time. So, that being said, I'd also like to point out that from this point on, the videos are sponsored by Anheuser-Busch. They may not know it, but I do, and that's also probably not doing me any favors when it comes to remembering it. Specifically in incredible detail. What we were going over in the previous videos. Um, I'm not lying on the floor or anything, but there's just I'm just gonna leave it at that. So, uh, that's that, yada yada yada, and we had the previous thing open in 321. All right, so what I want to go over is in their previous video, something that an example I was using was that we had let's open up let's get rid of that. Let's open up Shadow Returns here. New game, the usual jazz, groovy groovy. Yep, yep, yep. That things Yahtzee. All right, so we're done with that. Let's bring this back up. What we were doing is we had this thing. We had, oh god, we had Cheat Engine linked to Shadowrun, and then we had 321 right here. So, and then we also had Byte selected here. That doesn't make any sense, um, because as we talked about, I'll open up another copy of Notepad here. In the previous video, we talked about how um, the max value of a character is 255. Or 256 if I let's look it up. How about that? So we'll go here, go to Wikipedia. What did I don't know, 10 many videos ago, what did we search for? Assignedness. We can search for care. Um, yeah, let's do that. No, actually, let's just search for byte. All right, a byte. Unit symbol, common uses. Can we get a table that shows us the value of the byte? Kilobyte, binary prefix, blah 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 stuff. It's just I don't know, cut down 255. There you go. The C sharp, unsigned byte, signed byte, holding values from 0 to 255, negative 128 to 127 respectively. C sharp, it's close enough, it's good enough for me. So let's just we're just gonna say that it's 255. So that works. Um, so we're searching in Cheat Engine for the value of 321 against a byte, a signed or unsigned byte, and the max value that can hold is 321. Or I'm sorry, I just messed it all up. We're searching for 321 of a value type unsigned byte, and the max value that this type can hold is 255. So searching for 321 is going to be essentially pointless. Now, how does this tie into what we were talking about with bit patterns and stuff like that? Well, as we were talking about earlier, you have a bit pattern of a value of that, and then you can insert bits and whatnot as you have to. So the max value of that of a byte would be all ones, and that equals 255 in decimal. So what happens when we try and stuff 256, 257, stuff like that? What, as we've sort of gone over, and I'm going to glaze over it here, what happens is that this value rolls over and essentially becomes that, it equals 0. This is 0. It's also 256. If you want, and then you could scale this up so to the point where any multiple of 255 or 256 in the event that I'm off by one. Is it Yeah, I want to say it's 256. Is going to be 0. Now, can we make this concrete? Can we, are we talking out of our ass here? Can we maybe solidify this in a way that we can show with Cheat Engine and a game? Yeah, we can do something like that. So let's think up a contrived example here, and we're going to ask ourselves, all right, what's an easy value? I'm making this up off the top of my head, so bear with me. We're going to search for let's say 255 is the max. 256 is going to be equal to 0. So we want to do 0 plus 5. So that's going to be 261. So now we know that searching for 261 in decimal, when you convert 261 to binary as a decimal number to binary, and you stuff that value into a byte, what's going to happen is that the computer, the processor, the application, but mostly the computer, is what it's going to do is it's going to say, all right, this is the max value I can hold. You have one more. Oops. You have max value I can hold. You have one more than the max value I can hold. So there's that. And then you have one more than that. So I'm going to do that. So now I'm at 1. And then you also have one more than that. So now I'm equal to 2. And then that, and then 3, and so on and so forth. So what you wind up doing is you're rolling over constantly. We'll open up a calculator here. We'll do 256. No, that's not right. We're going to do 261 minus 256. It's going to give us 5. Close that. So now we know that 261 is equal to 5 because it's too large of a value, so it's going to roll over, and the remainder is going to be 5, and that's what's going to wind up in the byte. So we're going to try and set it up here so that our karma will be 5. Is what we're going to try and do. See if we can make that happen. All right, there we go. So 261. What are we doing here? We have 261 in the value. It's stuffing, and Cheat Engine is saying, okay, 261 converts that into a bit pattern, takes that bit pattern, stuffs it into a byte. The byte cannot hold that large of a value. The value rolls over, so the remainder is what gets left in the bit pattern. The remainder is 5. So by searching for 261, when we understand that the value types and the constraints on their values, we're really searching for 5. So let's change it. It's 3. So let's see how we're going to do that. We're going to take 261. We're going to subtract 2. It's going to be 259. Do a next scan. Do it a couple more times. Move the values a bit. We'll get rid of this one. Make it 4. So we're going to add 1. We're going to scan. There's 2 values. Just to prove that we're not completely retarded. Get rid of 1. 6. Now these values are 6. And just like we did in the previous videos, as far as the karma tutorial, we change 1. The value. Available karma is 98. Change this one to whatever we want our karma to be when we start the game. And you can see that we found these 2 values without ever actually having to enter what the actual value of the karma was. We used the rollover and the rules associated with it to find this value without ever entering this value into this box. Now that's a great trick and fancy stuff. How does that help us? Well, it helps us because when we start writing assembly scripts and things of that nature, we're going to have to sort of deal with values or deal with memory locations that are declared to as a certain type. So I mean, some memory locations will be bytes, others will be 2 bytes, 4 bytes, 8 bytes, floats, doubles, things like that. When we start moving stuff around with scripts or assembler scripts, whatever you want to say, you sort of get into this realm of you have to be careful about the values that you're smashing into these types. And knowing the rules regarding the rollover, not only does it help you make sure that you don't fall prey to those sort of things, it helps you identify mistakes. So what do we mean by that? Well, in the earlier example, or in one of the earliest videos where we were finding the value for karma, we were changing it, and we were playing around with all sorts of rules like that. We wound up having negative 73 for available karma. So, and we went over, why that is, how to fix it, and things like that, and edit it, and settings, and yada yada yada. But we can sort of reverse engineer that. Let's see, let me think this through real quick. See what happens if we set this. This is not actually a byte. This is actually 4 bytes. So anyway, we're gonna correct the contrived example up here. Set it to -1. Gonna do something. Be crashing the game or something? Oh, yeah. All right, because it's signed. So the game interprets signed values. So this huge value that we just put in here is being interpreted as a negative number, which is why we can't actually do anything. We go like that. We hit 7 and then 14 because it's rolling backwards. All right, so let's think about this a little more logically. How can we demonstrate this use in the real world? Not only can we find values without actually searching for the correct value, let's just confirm it. Go into the game. This is not super clear, is what we're going to call that. So we saw that we should have 107. We can delete this one because that's just the character creation. I have to start zipping through this because I'm close to the time limit. So we can see 107 for karma. That's great. We'll make it 5. Close the PDA. Go back to the PDA. We have 5 karma. It's awesome. All right. So let's make this value -1. We could do that. Let's get rid of this setting so that we can see what it would be if it was unsigned. This huge value here is -1. Go back in here, open it up. Karma value is -1. Now what we saw earlier was we had -73, so we could, for example, just to sort of bring this home, we got 429, 967, 295. Was that -73? We get that. Take that. Double click there. Paste it in. It might be off by 1, but I'm not really worrying about that right now. All right, so we have a ridiculous amount. We screwed that up. Let's see if we can maybe fix that a little bit. See what we do wrong. Do that. Yada yada yada. Do -1. Go here. Yep, -1. Yahtzee. All right. There's a simple mistake that I'm making. All right. Anyway, we can see it's the max value. Again, we went through this. We divided this by 2 and whatnot. But using the rollover, let me sum this up. Using the rollover rules, as long as you know the limit for the actual type, you can use the rollover to your advantage. And when you're writing assembly scripts, let's say that we meant to inject a value of 5 into karma. Just say we had some crazy assembler script or something like that. We wanted to inject the value of 5 into the available karma for the player. If we we do that in a script and then we come into the game, we force the script, we load it and run, and we see that our karma is actually like a negative value or not what we expect it to be. Knowing the rules to rollover helps you because you can sort of apply a generic test in your head and say, well, I expected the value to be 5, but it's not. Instead, it's -50 or something crazy like that. Change this just for clarity. So and then you could say, oh well, how did that value happen? Well, that value happened because you're accidentally doing something in your script where you're stuffing too large of a value into too small of a data type, and it's rolling over, and that's why you have spurious results, one might say. So again, not required to know, but this knowing the rules to rollover, why it happens, and how to deal with it, how to identify it, how to correct it, will go a long way when you start writing more complex scripts.